Welcome back, students. So in previous section we have done with data transfer instructions. So in this session we deal with arithmetic instructions. Fine, let's start. So these instructions, I mean to say arithmetic instructions perform the following operations such as addition, subtraction, increment and decrement. There will be no multiplication and division instructions in 8085. To perform multiplication in 8085, we do addition. Successive addition is followed in 8085. To perform division, successive subtraction is used. Fine. So let us start the operations one by one. The first addition operations. So what happens in addition operation? So any 8-bit number or the contents of register or the contents of memory locations. They have specified three things here: an 8-bit number, contents of register and memory location. So these things can be added. All these three things are 8-bit only. So all these three contains 8-bit only. 8-bit data has to be added with the contents of accumulator. It may be an 8-bit number or a register or memory location has to be added with accumulator only. Fine. This result, that is addition result, is stored back in accumulator. Fine. Whatever you add with 8-bit number with the contents of accumulator, the answer will be stored in accumulator only. You add with register, any register with accumulator, the answer will be stored in accumulator. You add with any memory location with the contents of accumulator, the answer will be stored in accumulator only. No two 8-bit registers can be added directly. So example, register B and C cannot be added directly, or BD cannot be added directly, or HL cannot be added directly, or H and E or H and B cannot be added directly. That means no two registers cannot be added directly. So one data should be there in accumulator, means addition should happen with respect to accumulator. Fine. So then comes subtraction. So any 8-bit number or the contents of register or the contents of memory location can be subtracted from the contents of accumulator and the result is stored in accumulator. Here in 8085, subtraction is performed in a 2's complement form. I think most of the students know what is 2's complement form. So subtraction happens in 2's complement form in 8085 microprocessor. If the result is negative, it is stored in 2's complement form. If subtraction, that is 2's complement form, the result is in negative, it is stored in 2's complement form. So you need to again find the 2's complement of that negative result, then you will get the original result. No two 8-bit registers can be subtracted directly. Even you cannot add directly. Fine. Then comes increment slash decrement. So the 8-bit contents of a register, any register, maybe A, B, C, D, E, H, L, or memory location, can be incremented or decremented by 1. It is just like for I is equal to 0, I is less than n, I plus plus. That is I plus plus or I minus minus, like incrementation or decrementation. So defaultly increment or decrement is done by 1. So the 16-bit contents of register pair can be incremented or decremented. 16-bit register pair. So what are the register pairs available in 8085? That is BC, DE, HL, SP. Another one is PC. That is BC pair, DE pair, HL pair, stack pointer, program counter can be incremented or decremented by 1. Suppose HL pair contains 8500. If I increment HL pair, it will become 8501. Fine. Increment or decrement can be performed on any register or on any memory location. Fine. The contents of memory location or memory location. So when they are dealing with memory location, it will be register pair they are using. When they are doing with any register or contents of memory location, it will be a it will be a 8 bit. Fine. Then comes next arithmetic instructions. Fine. Arithmetic instruction, first instruction is add r comma m, that is add register or memory to the accumulator. So add any register or any memory. The content of register or memory are added to the contents of accumulator. So register contents or any memory contents are added with the accumulator and the result is stored back in accumulator. Fine. If the operand is memory location, its address is specified by HL pair. All the flags are modified to reflect the results of the operation. That is add B or add M. Further in the next session we are going to go for some more instructions. Fine. Thank you.